Today we are stepping forward. We had been finding just the hypotenuse when the hypotenuse was not given to us. But today we're going to be talking about what happens if we're given the hypotenuse but not one of the legs, and seeing if we can use Pythagorean Theorem in that respect. So, just as a quick bit of review, what is the formula for Pythagorean Theorem? I should see 27 hands up in the room. Maybe 26. 2 people were gone yesterday. What is the formula or the equation for Pythagorean Theorem dealing with right triangles? Whitney. A squared plus b squared equals c squared. Perfect. What kind of triangles does Pythagorean Theorem work for? It only works for specific kinds of triangles. Anthony. Only right triangles. I'm going to put that only out there just as a point of emphasis. All right, so let's draw a right triangle below. I'm going to start by labeling where my right angle is. And it says label the legs and the hypotenuse. You should be able to do that on your own. I'm giving you a chance to get ahead of me. Label the legs and the hypotenuse all on your own. All right, and it says on the next one, find the missing side below. What work do we need to show? Well, we need to write a squared plus b squared equals c squared, but we have to know where those things come from. So what should I be doing on the triangle over here? Labeling it. First labeling my legs, then labeling my hypotenuse, then labeling my A's, B's, and C's. Remember, A and B are always the legs, and C is always the hypotenuse. 8 squared plus 10 squared is equal to C squared. Now it's just a matter of solving it, but we've got some simplification we can do. This is 64 plus 100 is equal to C squared is 164. Is equal to c squared. What's the inverse operation here I need to do to finish up this problem? Monique? Square root. Okay, sorry. I thought you said square it, which sounded a little bit weird to me. And I need the square root of 164 because that is not a perfect... Oops. Square root of 164. I know one perfect square root we've already talked about today was 13. What was the perfect square for 13? It was 169. So this is going to be really close to 13, but it's not going to be 13. Is it going to be more or less than 13? 164 is less than the 169, so it's going to be less. So this is probably going to be between 12 and 13. What's the perfect square for 12? 144. So is square root of 164 between the square root of 169 and square root of 144? Absolutely. So that's between 12 and 13. That's all review. Now for the new stuff. Let's get on with the new show. Now, that very one. All right, so first thing we need to do, label our legs and hypotenuse just as we did before. And label our A's, B's, and C's. A and B are always equal to the... What was that? To the what? Legs. He's switching up languages on me over here. And the hypotenuse is always equal to the longest, the hypotenuse, C. All right. So now when we use our equation here, a squared plus b squared equals c squared, we've got to be careful about what we know and what we don't know. Do I know a? No. No, so I have to leave a as a squared because I don't know. Do I know b? Yes. What is it? 12. 12 squared. Do I know c? Yes. It's 13. Squared. So I have a squared. I can go ahead and simplify 12 squared. I know that's equal to what? 144 is equal to 13 squared is 169. And what is it that I need to do here, do you think, to start getting a alone? Okay, so I'm hearing some people say divide, and I'm hearing some people say subtract. I like neither of those answers, however, one of them is definitely much closer.
Subtract.
So we have 144 added on, so we need the inverse of addition, which, Bianca, what is the inverse of addition? Adding the opposite. So we're going to add negative 144 to both sides. All right, so this cancels out, leaving us... Does this leave us with a?
No.
No. It leaves us with a squared. So are we done solving this equation yet?
No.
No, we're still going to have to do something to get just a. When we do this, we get 25 because we end up with 169 minus 144 is 520. So a squared is 25. Now, is the length of the leg equal to a squared? No, it's equal to a. What do I need to do to finish solving this equation? What is the last inverse operation that I need to do, Bianca, to get this equation solved? What is the last inverse operation I need to do to get this equation solved?
Let's see if she gets it.
Square it. We've got a squared, so we have to do the opposite of squaring it.
Oh, the nice one.
So Anthony, what do I need to do?
Find square root.
Take the square root.
Oh.
Square root of 25 is a perfect square, which is 5.
Got it.
So we know the length of that leg is 5 centimeters.
5.5.
Not squared.
Guys, stop playing footsie.
All right. What I want you to do is I want you to, in complete sentences, I want you to write, using appropriate math vocabulary, what we did in this problem to solve it and how it was slightly different than the problems we've done before. So do that on your own, and we will check back in 2.5 minutes. All right, so I saw a lot of really great things, people writing multiple steps, which is totally fine. Honestly, if you have a good understanding of solving equations and how to solve equations, it is actually as simple as you could write, it's plug known values into a squared plus b squared equals c squared and solve for the unknown. Okay, it could be as simple as that. Many of you wrote more specific steps. You wrote how you solve for the unknown in these particular problems. That's totally fine. Okay, I'm saying that if you know how to solve equations, and I know you know how to solve equations, this is probably a simple enough explanation. Because this is actually even more global. This works for even the problems that we did yesterday. Yes, Cassandra? And these are just a couple of problems to bring it to the real world, how you might see some of these things used in the real world.
Why? I'm curious.
It's on your paper.
I can't see it. What color?
So this is just kind of a problem that happens a lot in cities that have grid systems where the streets are in grids, much like San Francisco, but there's also sometimes a street that cuts across. Washington, D.C. is a grid system with things that cut across. And so a lot of times it's really interesting. We talk about walking from one place to another and what way would be fastest to go. And a lot of times when you think about it, well, we know if they walk down Market Street, maybe it's 5 miles. But if we walk the grid, how long is the grid? So what we see is that it creates this right triangle. And if we know some of the distances on there, we can find what's missing. So let's start by labeling the parts of our right triangle that are given to us. These are our legs of our right triangle. And this is our hypotenuse. And so I want to label my values. I'm going to label this leg as A. And this unknown leg as B. And our hypotenuse as C. If I want to know the unknown side, because this is a right triangle, we're going to use a squared plus b squared equals c squared, our Pythagorean theorem. And I want to plug in for a. I said a was equal to what? So that's 4 squared plus b squared. Did I know b? No. This one I didn't know. Equals c squared. Which is, I said c was... Dwayne, I said c was what? Dwayne, I said C was what?
5.
Perhaps if you were paying more careful attention, you would have been able to answer that more quickly. All right, so we can go ahead and do our squares. That gives me 16 plus b squared equals 25. And now I need to solve this equation. Well, what's been added to our unknown term? What's been added to our unknown term? 16's been added, so what do we need to do as the inverse operation, Alyssa? Add a negative 16 to both sides. So 16 plus negative 16 plus b squared equals 25 plus negative 16.
I'm not doing anything.
So that leaves us with b squared is equal to 9. Am I finished solving this equation? Is this telling me that it is 9 miles from here to here? No, it is not, because that length is b. So what do I need to find b, Esteban? What's my last step here to solve this? Yeah, take the square root of both sides. B equals 3. So this is 3 miles north. Now, if I go back to the original question, it says, who will walk farther? And it tells us that one person walks the hypotenuse and one person walks the grid system. So who walks farther, the grid or the hypotenuse? The hypotenuse is the longest side, but if you walk the grid, you walk 3 miles up and then 4 miles over. So you walk a total of 3 plus 4 is 7 miles. So is it better to walk the grid or is it better to walk the hypotenuse? Hypotenuse. That will be true no matter what. All right. Last problem. This problem is a ladder leaned up against a wall, and we want to know how high up the wall the ladder reaches. And we're told that this is it's 5 feet away from the wall, so this would be like the leg. And what's the other leg in this problem? Esteban. The 13 feet is not the other leg. If you think about it leaned against the wall, it's the wall's got to be the other leg. Because the wall and the ground make that right angle. So you think about your right angle as being right there. So I label my A. My wall is my B. That's trying to find out what it is. My ladder is my C. That's my hypotenuse. I'm going to leave you all on your lonesome to finish solving this problem. I'm going to check back in with you in about 1.5 minutes to see what we've got going on here. So go ahead and solve this problem all on your own. So here we should see that the ladder reaches 12 feet up the wall. We plugged in our leg, 5 squared and 13 squared, added a negative 25 to both sides. That gave us b squared was equal to 144. Take the square root of both sides, gives us b is equal to 12. And if we put our units on there, feet. Are there any questions about our work for today? No. Yes, Esteban. Yeah, so Esteban's asking a really important question here I think that we can all learn from. Esteban's saying, does it matter which one I label as A or B? No. I need somebody to, first of all, answer that with a yes or no, but also be able to back it up and mathematically explain why it does not matter. Ms. Banks.
I think it doesn't matter if you label it, because either way you're going to have to double, like, shooting.
Yep, so what I hear Selena saying is it doesn't matter either way, because either way you're going to be adding the opposite or squaring it, whichever term it is. So Selena's absolutely right. Because of the commutative property of this addition, it's totally fine to just plug in A or B. Doesn't matter which leg is which. All right? Excellent. Please move on to